Today I'm going to be analyzing the Bridges math curriculum. I chose second grade because I'll be working in a second grade classroom when I start my student teaching next quarter. I'm excited to share with you all about addition and subtraction math strategies at a beginning unit in the Bridges curriculum. This is my learning progression for the third module in the second grade curriculum, Introducing Addition and Subtraction Strategies. As seen in my learning progression, the big idea of this unit is that there's multiple strategies to solve addition and subtraction problems. Common Core greatly influences the Bridges curriculum. For example, in grade 2 in Operations and Algebraic Thinking, the first two curriculum standards match what this unit is about. For example, representing and solving problems involving addition and subtraction. All three lessons involve students developing different skills that they can use when they find an addition or subtraction problem and how to solve it. The second one really pertains, and that's Common Core Math Standard Math Content 2 OAB2, which is add and subtract within 20. All three lessons encourage students to really focus on understanding the relationships between the numbers and the combinations that you can make up to 20. Another important piece of the puzzle is that Common Core really puts an emphasis on students understanding and memorizing the number combinations between 1 through 20. So all of three lessons focus with numbers under 20 and them developing these combinations. So overall, the Bridge curriculum really matches Common Core. Overall, these math skills are really foundational, but they're really important because they play a part in the rest of the math that you're going to use the entire rest of the school year. So really focusing on how students have a bunch of strategies they can use to solve addition and subtraction with is really vital. Therefore, there's a really big emphasis on making sure students understand how they can add and subtract and what strategies they can use to do that. So these three lessons are all strategies students can use to do that. Chapter 2 in Van de Waal is a great resource to understand conceptual and procedural understanding. Overall, my conceptual understanding is very much similar to what it says in the book. Conceptual understanding is a knowledge about the relationships or foundational ideas of a topic. Through all three lessons, students are understanding that you can combine numbers together, but you can also take numbers apart, meaning that you can add 10 plus 10 to equal 20, or you can do 20 take away 10 equals 10. My lessons focus a lot more on procedural fluency because students are investigating many strategies in order to solve addition and subtraction problems and different ways to persevere through that problem solving process. And that perfectly explains what Van de Waal is saying as well. Procedural fluency is knowledge and use of rules and procedures used in carrying out mathematical processes, and also symbolism used to represent mathematics. All three lessons focus on different strategies that students could use, but they're also focusing on how they can create equations to show their work. I think Van de Waal says it perfectly when it says procedural fluency is a skill in carrying out the procedures, flexibility, accuracy, efficiently, and appropriate. So basically, my lessons focus right along with that because it's developing different skills students can use when they see a problem. So when they look at one problem, they can see, oh, I should double this one, instead of just maybe using the traditional algorithm. All three lessons don't focus on using the traditional algorithm at all. Mainly it's focusing on using the number racks and using their fingers to solve, and then going up from there figuring out, oh, if this is 10 plus 10, that equals 20. But if 10 plus 11, well, I know 10 plus 10 is 20, plus 1 would be 21. So my strategies are focusing students on using other ways. All three of my lessons truly match with the Common Core standards for mathematical practice. You can tell that they're truly ingrained in the Bridges curriculum, at least in my second grade unit, but it definitely uses many models. Students are really having to make sense of the problems before they're solving, meaning students are like, what is the best strategy I can use when solving said problem? So like I said before, if they know 10 plus 10 equals 20, then they can solve 10 plus 11 using the doubles method. So each of these methods they're learning just gives them another strategy to add to their tool, like their toolkit they can use when solving addition and subtraction problems. All three of my lessons also involve students constructing viable arguments and critiquing the reasoning of others as well as their own. They truly have to decompose the number combinations in each of these lessons and defend their answers and being like, well, I know this because of this. There is also a heavy use on number racks and fingers, meaning they're using appropriate tools, but they're also using other counters during these lessons, so they're definitely using a lot of math tools. All three lessons also focus on students being able to recognize pattern and structure. Students are having to look for doubles, meaning they're trying to figure out what's the relationship between 5 plus 5, 4 plus 4, 10 take away 5, 8 take away 4. They're trying to figure out why are doubles such an important strategy when doing addition and subtraction problems. This big idea in second grade is actually very important because it relates to many big ideas that students will have to use the rest of the entire school year. These are very foundational math skills, meaning that these skills are used the entire rest of the year. I only covered 3 lessons in this unit, and so other big ideas that are involved are there's multiple ways to show my thinking when it comes to addition and subtraction. If you look on my learning trajectory, you can see there's about 10 other ways that students can solve addition and subtraction problems, and that's not including invented strategies. So there's many strategies that students can use. It's also important that students are developing these skills because another important big idea in the future is that some strategies are more useful in certain situations than others. So, for example, it's easier to use doubles for 5 plus 5 versus counting on your fingers 5 and counting on, so 6, 7, 8, 9, 10. If students automatically know the double 5 plus 5, then that can save them time when solving a math problem. Other big ideas would be that they need to start modeling and solving story problems. So these basic combinations of math pairs under 20 are really important, especially as they move on to double-digit story problems. And they need to be able to have these skills so that they can model what they're thinking. Also, this will also play a huge role in place value as students start decomposing numbers, and they need to be able to understand how to add and subtract. That would play a big role in comparing numbers in place value. As you can see in the upper left-hand corner of my learning progression, you can tell that there's some prerequisite skills that students should have before they approach these group of lessons. A lot of these skills are skills that students worked on in kindergarten and first grade. For example, a prerequisite skill would be that some students should understand some basic number sense. Number sense refers to a student's fluidity and flexibility with numbers. They understand what numbers mean and their relationship to one another. And I mean this on a very simple level, knowing that 5 becomes before 6, and 6 is 1 past 5 on a number line. Those are some basic number sense that students could have that would truly help when discussing some of these math problems and solutions and strategies in these next couple lessons. Another one would be if they understood some basic number combinations as well. And this is talked about in kindergarten and first grade. For example, Common Core states that kindergartners need to represent and solve problems involving addition and subtraction. They also can add and subtract within 20 and relate counting to addition and subtraction, counting on by 2 to add 2. Add and subtract within 20, demonstrating fluency for addition and subtraction within 10. That's discussed in kindergarten, and if you think about it, think about my learning target that is for my second graders. They're trying to focus on number combination fluidity up to 20. So that's already half of the combinations. They're working on the other half. And then also making sure that by the end of second grade, that all the number combinations under 20 are memorized. Like it's automatic that they know that 9 plus 9 is 18. And that's focused on through the double strategy. Or if they know that 10 plus 9 is 19, because they know 9 plus 9 is 18, add 1, that's 19. All of my skills are just taking upon the number combinations that they've already learned about to some degree, probably by the time they enter second grade, and depending on the time of the year that this is discussed as well. Also, some preliminary experience with math equations. As I was looking at these lessons, they definitely, especially by the third lesson, encourage students to start using the addition sign and the equal sign. And by the time that they get to second grade, they already have some experience with that, as I learned by looking through Common Core. Students are already representing and solving problems involving addition and subtraction. Um, they are adding and subtracting within 20. They're using symbols to show their addition and subtraction. Um, all of these students are already starting to do these in kindergarten and first grade. So really it's just going with that knowledge, pushing it forward to focus on even more number combinations so they can really be memorized. And also, it's important is focusing on these strategies. That's what's even more vital. Yes, you want to have the number combinations memorized under 20. That will lead to further success in other math problems, place value, all of these other things that are other big ideas beyond this one. But if you understand the strategies behind it, you can use that when solving double-digit numbers. It leads to further success in math because you're building up that toolkit, like I said before. And if you have a bigger toolkit, then you're more prepared when you see another math problem in the future. And I think that's the big emphasis on these 3 lessons is if you have a bigger toolkit, you're more ready to show your thinking and you have more ways to investigate a problem. You have more ways to start a problem. My learning progression has 3 learning targets that help build up the big idea that there are multiple strategies when solving addition and subtraction problems, as well as a variety of tools available. My first learning target is learning target 1. Students will be able to use their fingers and number racks to investigate doubling and halving as an addition strategy. I think this is a great way to start because this learning target has students using their fingers to model math, which I know many students have been using since kindergarten. It has students using their fingers to double numbers. For example, show me 4 fingers on one hand. Now double it. How many fingers do you have now? 8. Then it has students using number racks to explain their thinking, which is another great math tool. This introduces to students that numbers we can double can easily be added together, or vice versa. Numbers that we can have make it easy to subtract. This is great because it shows students another strategy that we can utilize when solving an addition or subtraction problem. The second learning target is students will be able to use their number racks to investigate the doubles plus or minus 1 facts. This learning target builds on the previous lesson because it has students using the number rack to explore other combinations under 20. It has students using the double strategy but then either adding 1 or subtracting 1 to find the solution to the problem. Students use the number rack to display their thinking, and this connects to the big idea because it's another strategy for students to use when they approach an addition or subtraction problem. Basically, the strategy just goes a little bit beyond the one introduced the day before. So just when students understand the doubles and halving, this extends that knowledge further to help with other math combinations. The third learning target is students will be able to determine how many different ways a number of guests can be seated at a dinner party through decomposing number combinations up to 16. This interactive lesson has students placing beans around a table that have students physically creating different equations using a variety of number combinations. If students starting with a sum and has students manipulating the addends around a table with 2 different shaped plates. For example, if you have 13 guests, you could place the beans around the table in a variety of ways. 9 guests could have square plates, and 4 guests could have circle plates, creating a math equation of 9 plus 4 equals 13. This is students decomposing numbers and creating equations to solve addition problems. This relates to the big idea because using manipulatives is the way students can solve addition and subtraction problems. Also, using equations is another strategy that students can use to show their work as they interact and solve addition and subtraction problems. I ordered the learning targets in the way that I did because they build off of each other. Doubles start there, then doubles plus 1. Then I have this bean activity, and the bean activity is the one where you're definitely using the prior knowledge you gained in the other 2 strategies to incorporate that into the bean strategy. Yes, you could just place the beans as you want, but if you're encouraging students to also think about, okay, we're placing 8 beans around the table. Can we break in half 8? Oh, you could have 4 square plates and 4 circle plates. But are there also other ways you could do that? And then encouraging students to actually manipulate it. All of these build up off of each other so that these strategies can be used just as they are, but also used in combination. That's where it's really critical. So, do I think it'd be easy or difficult? I think both. I think some parts of these lessons can be very simple, and I think a lot of students will understand what it means. But I also think some of these will be really difficult for students, and I know it says that it will only take 3 days, but realistically, I think it would take a lot longer. Like, not a lot, but definitely would take a few days or a good chunk of time. Hopefully you're spending a good chunk of time when you're doing math each day that you really can hone in on these skills. For example, I think that most students are going to understand doubling fairly simply, especially because by the time they leave first grade, they have number combinations up to 10 basically memorized, or at least hopefully by the time they get to second grade, or at least they have some background knowledge when it comes to that. So mainly for the doubling, you'd be focusing on finding the doubles from 10 to 20 to be memorized. And then, of course, going beyond that, but at least focusing on those ones to make sure you have all of the doubles. And then I think halving would be a little bit difficult. I think that involves a little more of your brain. Like, they both involve your brain, but for me personally, I can double a lot faster than I can halve. And I'm not sure why, but I think mainly it's students maybe develop their addition skills first before bringing in subtraction. Yes, they're a little bit like at the same time, but you're focusing more on addition and then you're bringing in subtraction. So I think that's why having could be a little more difficult, just because you have to think in reverse. So thinking in reverse, I think, could be difficult for some students, especially if they're maybe more confident with addition versus subtraction. And I think that's very common in elementary school, that some students are really good at both. Some students maybe have a preference of which one they're better at. And for me, that was addition as a kid. So I definitely understand where that would be a little bit easier for me to grasp on. What else would I think would be difficult would be some of the language in this lesson, in all three lessons, because it's very heavy language support would be needed if you didn't have English as a first language. Hi, I also think that creating equations could be an area of difficulty for these lessons. Of course, by the end of first grade, according to Common Core, students are already working with addition and subtraction equations and they understand the meaning of the equal sign. But I think since the problem is having you discuss multiple ways that you could create those numbers using the beans, and I'm meaning the third lesson where they're finding different ways they can make 8 or 12 or 16. I think for some students that might be a little bit difficult to find multiple solutions. You definitely would need to focus on persevering as a classroom to find all the solutions that you can, which if you have a great classroom environment, I think that'd be great. But I think also I could see where some students could get frustrated if they can only think of one way. And if they think that's the only way to solve the problem, when realistically, a lot of those problems have multiple ways. So I think just making sure as a classroom you have an environment where you want to keep encouraging more thinking always would be very important as well. Academic language is very important when it comes to mathematics because terminology helps us understand what we notice about numbers, and it gives us an opportunity to express ourselves and to explain what we see in math. But academic language can be very difficult, especially for students where English might not be their first language. Personally, I've had some experience with students where English is their second or possibly third language. And academic language is one of the most difficult things for these students to understand because it needs to be explicitly taught. It can be a whole new word that may be a word that they don't understand, maybe even in their first language. So it's really important to help bridge this barrier with students, especially with our ELLs. Academic language is really strong in math, but it's very important because it gives us something that we can all discuss. And there's a lot of academic language in all three of my lessons. If I was teaching these lessons, I definitely would be using a lot of TPR, which is total physical response. I also would be trying to bring in a heart language. So if I had a lot of students who spoke Spanish or Mixteco at home, I would try to find a word that translates to that so that maybe we could incorporate both words to help just help bring in that heart language that those students can confer in their first language to help work together and solve problems. I also, a few words that just are really difficult for all students would be compare, equal, doubling and halving, equation, and also the addition symbol and subtraction symbol, as well as the equal sign. All of those signs and notation are going to be very difficult, and those are going to be conversations you're going to have in your classroom. Because what exactly does the addition symbol mean? What does the subtraction symbol mean? Especially the equal sign. We're just getting ready to discuss that in our class, and I'm even having trouble understanding what that means in college. So you really need to discuss what it means when you're working with your students. Also, arrangement. That was kind of another word that Bridges curriculum recommended. What's really awesome is the Bridges curriculum outlined kind of some of the words that definitely are academic language that would need support, and arrangement was one of them for my last lesson. Overall, it's just honestly very critical in these lessons that students understand what doubling and halving mean, because those words are used in two of my lessons at least, and probably you're going to incorporate that in the third lesson. So you really need to break down what doubling and halving means, and it kind of does that in that lesson, but you really need to make sure you're using that strong academic language as you're teaching that, and not just casually saying that. You need to be, this is doubling, I think, very explicit, and having posters and having students come up and model it with their bodies. You could have 4 students stand on one side of the classroom and then be like, what would double of these students be? How can we double that? Let's double it together, and then have 8 students on the other side showing the double. I think that would be very beneficial for all students, but especially students where English might not be their first language. Also, equation, because that's the written way to show the expression that they're discussing, especially in the last lesson. And equation, that can be a difficult word just to describe to someone who already speaks English, but definitely you need to have a big discussion as a classroom, because that expression will help lead you through the rest of the lessons beyond my third one. So it's really crucial for that academic language to be discussed.